Welcome to solverfy.
In this problem, we're asked to determine the polar area moment of the shaded region that is a square with some half circular holes cut in it. And we want to find the polar area moment about the x and y axes, which are or have an origin down here. So in this problem, what we're going to do is we're going to well, it's easy to find the polar area moment, or the area moment, of this square about this point. So we'll do that, and then we'll find the area moments of these two cutouts about this point and subtract those area moments from the area moment here. So the area moment of this guy, since it has a width and a height of 4a from at its corner, is 1/3 4a to the 4th power, or 256 over 3a squared, and that's the same for x and y. Obviously there's symmetry about that axis. And we can now get to the more difficult part of finding the area moments of these cutouts about this point. So we found, in a previous problem, we found the area moment of a half circle, or a semicircle, about its centroid. And that was pi over 8 minus 8 over 9 pi times a to the 4th. These have a radius of a. And y, about the centroid, is just pi over 8 a to the 4th. Now, we can figure out the area moment with respect to this point by using the parallel axis theorem. And so we have the area moment about the centroid of this run times its area, or plus its area, times the distance from this x-axis to the x-axis of the centroid squared. And that is, it's 3/2 a up to here, and then minus 4 over 3 pi down to the centroid. So that's the distance squared there to this centroid. And then for y, it's a little simpler. We can plug this in and then do some algebra and simplify this, and we get 4 a to the 4th over 4 times 8 plus 5 pi is the area moment about this x-axis of this region here. Now, y is a little easier because the centroidal moment is simpler, and then the distance here is easier, and that is just 2a. So that all becomes 17 pi over 8a to the 4th. And now if we look at the upper hemisphere, or semicircle, we get, again, its area moment about the x-axis is its area moment about the centroidal x-axis, and that's the same as for this one here, since these have the same shape, just rotated 180 degrees. And then the distance, then the area times the distance squared, and I think I forgot a square here. The distance squared, that distance, it was 5 halves a up to here, and then we add another 4 over 3 pi a to that, and so we get the area moment about the x-axis that we're looking for as this. And then we can see that the area moment about the y-axis is the same as for this one, because these two are just rotated and flipped and translated about the y-axis, so they're going to have the same area moment about the y. Now we can figure out the area moments about the net shape by taking the square minus the semicircles. And if we do that, that becomes a to the fourth over 2 times the quantity 160 minus 9 pi, or about 65.86 a to the fourth. And likewise for y, we can take the area moment with respect to y of the square and minus that for the semicircles, and those two are equal, so we can just multiply that by 2, and that gives us a to the fourth over 12 times 1024 minus 51 pi, or 71.98 a to the fourth.